All right, guys, what is a secant line? We used it when we did average rate of change. You're right. So here is a secant line right here. What does it do? Okay, it crosses in 2 points. Yes, we use it to find average rate of change. Yes, but it is a line that touches a curve at 2 points. So that was a secant line. Then down here goes, this is a tangent line. What does it do? Yeah, so it's a line that touches a curve at 1 point. All right, so that's not hard. Definition, secant, tangent, we're fine. Okay, so would you agree, like here's a secant line, right? It goes through those 2 points. I move those 2 points closer together. Still a secant line, right? I move them even closer together. Still a secant line, but what am I getting closer and closer to? The tangent line, right? Now, with these, I've got points P and Q every time. And you guys were saying, oh, average rate of change. Like, we can find the slope when we have 2 points. On my tangent line, the only point I see is P, so that's a little trickier to find the slope when you only have 1 point. So what we're doing when we're finding the slope of our tangent line is we're picking the secant line that is as close to that tangent line as we can get and still have 2 points. So, look at this picture here. I'm not really concerned with the delta x and delta y. I'm going to label this as h, like that horizontal distance. Do you agree that that's the horizontal piece between P and Q? So if point P here is x, comma, f of x, Q then would be x plus h, comma, f of x plus h. Right? Like I've just moved sideways. Okay. And we know slope is change in y over change in x, right? So how would you tell me the slope of the secant line I have right here? What's one of my y values? Okay, f of x plus h minus, okay, over, minus, so doesn't that simplify to f of x plus h minus f of x? I was, oh my goodness. So, and now one more piece to just put it all together for you. If I'm looking for the tangent line, like if I'm bringing these P and Q closer and closer together, what's happening to H? Smaller, like it might be approaching 0. Okay, so the slope of the tangent line,
slow down here.
I know, mind-blowing. It's the limit as H approaches 0 of f of x plus h minus f of x all over h. So that wasn't just a random me giving you a weird thing to plug in for your limit, okay? That was a purpose. All right? And that's how you find the slope of your tangent line. Does that make sense, guys? Because with our tangent line, we only have 1 point, so let's use the slope of the secant line that's really, really close to that tangent line. All right. So far, so good? Mind sufficiently blown for the day? Okay. Good. All right. So what this is, I think I have to turn the page, you don't. You guys, that's a derivative. So we already talked about everything that's in a box. So the slope of a tangent line is called the derivative. These are all the different ways you may see derivative written. The first 3 are the ones we're going to use the most. F prime of x, that's how you say that, dy dx, and y prime. I mean, just be aware, those are all different ways to write derivative. Okay. Okay, so now let's use this. D. We're going to do, you'll do a lot of different stuff with a derivative, so pretty much most of what the rest of the unit is. This is, yes, we are into calculating now. Yep, we're into calculus now. Yeah. This is on the final. This pre-calc honors covers a lot of calculus. All right, so let's do the first one here. Find the slope of the tangent line to this curve when x equals 1. So you could, make a graph and try to find points. You do not have to do that. We can use our limit definition. So we are talking about finding the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, that's what we're finding. Yes, I'm writing that over and over because you do need to know that. That is the limit definition of a derivative. I will ask you to do them that way on a quiz or a test, even after you know the shortcut. Shortcut you can check yourself with, but you still need to do this the long way. Okay, so we know that x is 1, right? So really what I'm trying to find is the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. So how would I find f of 1 plus h? Plug it in. So I would have 3 minus 2 times 1 plus h minus 2 times 1 plus h squared. Okay. Then it says minus f of 1. Well, minus, I'm just plugging a 1 in now, right? So 3 minus 2 minus 2. Are you guys with me on that? Yeah, that looks just like a lot of numbers, but do you understand where those are coming from? Anybody lost? Please ask if you are not seeing something. Yeah? Not fully there. Okay. So f of 1 plus h, that's where I started, right? So anywhere there's an x, I'm going to plug in a 1 plus h. So the 3 is just a 3. And minus 2 times 1 plus h. Minus 2, 1 plus h squared. All right, then minus f of 1. Okay, so that means minus plugging a 1 in here. So minus 3 minus 2 times 1 is just 2. And minus 2 times 1 squared, that's 2. Yep, you're using that original f of x. Yeah. So it's like what you did in the warm-up. You're just evaluating this, but we plugged a 1 in instead of the x. That's all that's different. You could have done the whole thing with the x and the h, and then your answer at the end plugged a 1 and 2. Either way, that's not random. All right, so let's do some simplifying here. All right, I have a 3. And then that'd be minus 2 minus h, right? 1 plus h squared, I would just do that off to the side. That's going to be 1 plus 2h plus h squared, right? Yep. Thanks. Thanks for telling me now and not later. And then multiply by negative 2 for all of that 1 plus 2h plus h squared. So minus 2 minus 4h minus 2h squared. And then what is 3 minus 2 minus 2? This whole thing's negative 1, right? Minus negative 1 plus 1 all over h. Okay. So I've got 3 minus 2 minus 2 plus 1. What happens to all of those? Yeah, they're gone, right? 3 minus 2 is 1. Minus 2 is negative 1. Plus 1 is 1. Negative 2h minus 4h, what does that really become? Nope. Sorry, I'm running over. So I've got negative 6h minus 2h squared all over h. So, yeah, sorry, I know I'm writing small here. So what am I left with then? Like, what can I factor out? The h is really all we care about, right? That's going to go away. So this is really the limit as h approaches 0. That's an arrow. Of negative 6 minus 2h. So what am I left with when I plug it in? Negative 6 is your answer. Okay. You can see how it's just a whole bunch of algebra. What? The slope, yeah, so it's like m equals negative 6. So guys, what you found was the slope of the tangent line of this graph where x equals 1. So like you graph the whole parabola, it's upside down parabola, and then when x equals 1, you have this slope of negative 6. So you could think about like, so wherever this parabola is, and then over here at x equals 1, if I found the slope of that tangent line, it would be negative 6. Okay? That's what you're finding. Yes. Because you're trying to make that distance between your P and your Q really small. Let me go back and show you on this picture. See how the horizontal distance between P and Q is h? So as I bring those closer and closer together, do you see how that h gets smaller and smaller? Like almost 0. Okay, yeah. That's why it's 0 every time. All right. Ugly algebraically, but doable. Let's try again. And let's do, yeah, we'll do number 2. Should we do it together again? Or do you want to try? You want to try? All right, I'll let you start. You guys try. I'll give you a minute here. I'll take a minute, and then we'll go through it together. This one's actually easier than the first one, I think. It's a lot less messy. Yeah. Are we getting -1? Yeah. Negative, I know. Yeah, unfortunately with these guys, there's so many little places where you can mess up a negative or, you know, forget to distribute a 2 like I did in the first one or anything like that. Like there's just little tiny things that can throw you off. How do we feel about it? Yeah, Sarah. What? The final answer? What's f of... I'm sorry, Sarah, I just can't hear you very well. So you get 1 over 1 plus h? -1 over 1 plus h, sorry, yes. And so then you can just plug in your 0 and you get -1. Question so far? Okay. Number 3, guys, this is the same thing. You're just given a point. Instead of just giving you the x value, it's giving you the x and the y, but that doesn't really matter. You would do the same thing. You're finding the derivative and then plugging in to find the slope. So let's try one on the next page. Anybody questions about this before I move on? Okay, so go ahead and turn the page for me. Let's do this. All right, so number 4, find an equation of the tangent line. So it's very important you guys read your directions in this unit. The last one I asked you to find the slope of the tangent line. Now I'm asking you to find the actual equation for the tangent line, okay? So we know, you guys know this, right? Y minus y1 equals m times x minus x1. You know point slope? Okay? I'm giving you the point. I'm giving you this 1, 1. So what do we need to find? Yeah, slope, which is what we were just doing. That's that whole limit as h approaches 0. And you're given an x value of 1. So let's find it. So limit as h approaches 0. So f of x plus h. So that's going to be 1 plus h quantity squared. You guys see it? And then minus f of x, well, that'd be minus 1 squared over h. Are you guys okay on that step? If you need to see it with the x and the h first and then plug in the 1, like that's fine. I do not care which way you do it. All right, so if I simplify this, h approaches 0. 1 plus h squared, that's 1 plus 2h plus h squared, and then I have minus 1 all over h. So what can I get rid of here? The 1's are gone, right? And then if I factor in h out, do you guys see how I'd be left with just 2 plus h? Yes, no, maybe. Yeah, okay, I'm seeing some head nodding. So it is 2. So that means slope is 2. And then you've got this point. So could you write the equation now? Y minus 1 equals 2 times x minus 1. And if I don't ask for it in slope-intercept form, just stop there. Like, that's it. That's the equation of the tangent line. Okay?
So how do you finish simplifying?
On the limit part, it's you simplify until you can plug in that 0. Like now I can plug in 0 and it won't be an issue. The step before, I still had an h in the denominator.
Oh, plug in like 0
For h, yeah, because h is approaching 0. Okay? All right. We okay there? All right, so 5 is going to be the same thing as what we just did. You'd have to find the slope, use the point, plug it in. What is 6 asking you to do? But did I give you a specific x value? No, so I am just asking you to find the limit as h approaches 0 of f of x plus h minus f of x all over h. That's what we're doing on 6. So let's do that one, and then I just want to talk about one more thing and we'll be done. So limit as h approaches 0. So f of x plus h, that's going to be x plus h squared plus 10 times x plus h. And then minus f of x, so minus all of x squared plus 10x. And that is all over h. All right, for calculus notation, like on free response, as you're going through and simplifying, each step has to be equivalent to the previous step. If you want to do some of the simplifying off to the side, that's completely fine. Like if you want to be like, okay, x plus h squared, I know that's x squared plus 2xh plus h squared. And then I'm going to have plus 10x plus 10h minus x squared minus 10x. Like if you want to do that all off to the side and then just write the simplified part in your limit, that's great. You just can't sort of do that in the middle of the problem and then go back to the limit notation, okay? But you can certainly do that off to the side and then be like, okay, I am left with limit as h approaches 0 of, let's see, my x squareds are going to be gone. My 10x's are going to be gone. So I am left with, it looks like, what, 2xh plus h squared plus 10h. And what can I factor out of all of those? H, yeah. So 2x plus h plus 10 all over h. Can I get rid of my h's then? So those are gone. Now can I evaluate the limit? Yeah, and what am I left with? 2x plus 10. So that is the derivative of your function f of x equals x squared plus 10. It means slope of the tangent line. Yep. And so that is the equation for the slope of the tangent line at any point on this curve. You know what I mean? Like I could have said, so you found the derivative, I could now be like, okay, what's the slope of your tangent line at x equals 2? Okay, you plug in 2. Or I could be, what's the slope of the tangent line at x equals 73? Got the formula now for the slope of the tangent line at any point. Okay?
So that's like that.
Yeah, so if you'd rather do it that way and then just plug in whatever your x value is, that's fine too. Yep, absolutely. A lot of this is terminology and getting comfortable with what am I actually asking you to do. So it's going to take some practice. Last thing real quick. Oh, Anna? Well, hold on. We got to just talk about one thing real quick. So 3 common ways where you wouldn't be able to find the derivative. That's what it means to fail to be differentiable. It means you can't find the derivative at that point. First one is if you have a sharp point. So you guys see this point up here? You would not be able to find the derivative. Oh, that froze. Okay. So I have this point up here. See this? Okay, you would not be able to find the derivative at that point. Okay, it's this pointy thing. You can't find the derivative. The reason being, do you see how many tangent lines I could draw through here? Like, well, that's tangent at that point. That's tangent at that point. That's tangent at that point. There's an unlimited number of tangent lines, so it doesn't work. Okay. Let's see. The next one is if it's discontinuous. So you guys have like the jump and the hole on your graph there. You can't find the tangent line if it's not like one specific place that you're finding the tangent line for. And then the third one, vertical tangent line, that's where it's got a point of inflection in the graph. You can't have the undefined slope of the vertical tangent line, so that's why that doesn't exist. Okay? I know that's a quick run through on those, but yes.
So for 6, we found like 2x plus 10 is the derivative?
Yes.
So that means like on the graph of x squared plus 10x, if we use that formula with any point anywhere.
Yep, any point on the graph, you could find the slope of the tangent line through that point. Okay? Homework on your assignment sheet. Yeah, let's do that. So guys, page 762, 339, multiples of 3. What does it say in your assignment sheet? Yes. Yes. There you go.
Yeah, a lot of us are going to
Yeah, I'm not going to be here.
Is that Wednesday?
We'll figure it out.
Yeah.
There's a place that's lost.
I'm not gonna be here on
Quiz
Wednesday.
next class, yes. You're supposed to be. And a lot of you are gone. I think it's about half of you. Not quite half. All right, guys.